Welcome to The Explainer. Today we're digging into the AI revolution. It's a technology that promises to change, well, everything, but it's also kicking up this intense storm of debate and even fear, often from the very people who know it best. And that brings us to our first puzzle. This is Douglas Hofstadter, a legend in AI and cognitive science. And he's not celebrating the incredible breakthroughs we're seeing. He's terrified. And he's not just saying that, he actually confessed this deep fear to a room full of Google's best AI engineers. So what's he so scared of? It's not the Terminator, not some killer robot apocalypse. No, his fear is much deeper. It's more philosophical. It's the dread that everything we think is special about us, our intelligence, our art, our feelings, might actually be disappointingly simple. That the human spirit could be reduced to just a bag of tricks that a machine can easily copy. To really get what he means, we need to pop the hood and see how this stuff actually works.
Okay, so what is this technology that's suddenly everywhere, from your phone's camera to brand new medical discoveries? It's not magic. It's a very specific kind of engineering.
Here's the most important thing to get your head around. Almost everything we call AI today is really a specific technique called machine learning. Instead of a programmer writing thousands of lines of code with explicit rules, they design algorithms that can learn the rules on their own, just by chewing through massive amounts of data. In a way, they program themselves.
So how do they do it? Well, at the heart of it all, you have these things called artificial neural networks. Now, they are inspired by the structure of our brains for sure, but, and this is a big but, they don't actually imitate it. Each one of those little artificial neurons is just a simple math problem. It takes in some data, decides how important that data is, and then passes a signal along. But when you link millions or even billions of them together, you get a machine that can learn in incredibly powerful ways. The most common way they learn is through a process called supervised learning. Let's say you want to teach an AI to recognize a cat. You don't tell it about whiskers or pointy ears. You just show it hundreds of thousands of photos that a human has already labeled cat. Each time, the network makes a guess. If it gets it wrong, it nudges its internal connections just a tiny bit. You repeat that process millions of times, and eventually it gets incredibly good at spotting cats. And this right here, this gets us to the central paradox of modern AI. These systems can develop superhuman abilities in very specific areas, but at the same time, they can be surprisingly fragile. They have absolutely no common sense. Just look at AlphaGo. It was trained to play the ancient, mind-bendingly complex game of Go, and it didn't just beat the world's best player. It did it with moves that Go masters called beautiful and creative, moves that they said no human would ever have even considered. It was a huge moment. But that incredible performance forces us to ask a really fundamental question. Does the machine actually understand what it's doing? Or is it just a pattern-matching machine on a scale we've never seen before? Well, the evidence suggests it's the latter. You see, when you give these powerful AIs very simple, abstract puzzles, like these Bongard problems, they just fall apart. The task is easy for us. Figure out the one simple rule that makes the 6 boxes on the left different from the 6 on the right. A child can do it. But for an AI that has no real-world experience to draw on, it's an almost impossible task. And that really drives home the difference between how we learn and how they learn. A child might need to see a cat once or twice to get the concept. A deep learning model needs millions of labeled photos. And even then, it's shaky. If you train an AI on 1 million pictures of cats inside houses, then show it a cat up a tree, its performance can just tank. That inability to generalize is a massive hurdle. This brittleness also leaves them wide open to something called adversarial attacks. This is wild. Researchers prove that just by putting a few carefully designed stickers on a stop sign, they could fool a self-driving car's vision system into classifying it as a speed limit sign. It's not seeing a stop sign like we do. It's just recognizing a fragile statistical pattern, a pattern that's surprisingly easy to break. So if the AI we have today is this fragile, what about that big science fiction dream of a true thinking machine? That dream has a name, Artificial General Intelligence, or AGI. This isn't an AI that's just good at one thing. This is a machine with the flexible, common-sense reasoning of a human being. It can understand, reason, and learn pretty much anything. This has been the ultimate goal of the field since day one.
So when are we going to get there? Well, if you ask the experts, the people who are actually building this stuff, you get a dizzying range of answers. You've got inventor Ray Kurzweil, who's famously predicting we have a 50-50 shot by 2029. Then you have roboticist Rodney Brooks, who says maybe 2200. I mean, that's not just a disagreement. That's a huge chasm of scientific uncertainty.
AI pioneer Jan LeCun has the perfect metaphor for why this is so hard to predict. He says, with deep learning, it's like we've been climbing this big hill, and we're making amazing progress. But as we get close to the top, we can finally see what's on the other side. And it's not the finish line. It's a whole new series of even bigger hills, mountains really, that we never even knew were there. Every advance reveals just how much more there is to figure out.
And this brings us to what might be the most urgent part of this whole conversation. Because, while debating a far-off superintelligence is fascinating, the really pressing questions are about the powerful yet brittle AI that we are using right now, today.
We're already grappling with these massive dilemmas. How do we stop these systems from just soaking up and amplifying all the human biases in the data we feed them? What does our society do when it's not just factory jobs being automated, but creative and intellectual work? Are we really ready to let autonomous weapons make life or death decisions? And how do we make sure all this technology doesn't destroy our privacy?
Because of these immediate problems, some top researchers like Andrew Ng argue that obsessing over a hypothetical evil robot apocalypse is a huge distraction. He famously said it's like worrying about overpopulation on the planet Mars. It's a problem we might have one day, sure, but we haven't even landed there yet. And it stops us from solving the very real issues AI is creating for us right now, here on Earth.
So, there's one thing to take away, it's this. Artificial intelligence isn't some alien mind from another dimension. It's a mirror. It's built from our data, trained on our behaviors, and it learns from the digital world we've made. So it reflects everything right back at us. Our knowledge and our creativity, yes, but also our flaws, our prejudices, and all of our blind spots. And that brings us right back to where we started. Maybe the quest to build an artificial intelligence will never actually produce a truly thinking machine. But maybe its real value is what it forces us to do along the way. The pursuit of AI holds up a mirror and asks us to define what intelligence, creativity, and consciousness really are, and in the process, to figure out what it truly means to be human.